Hello everyone, I am Ramakrishna, working as Assistant Professor in the CSE Department at VIGNAna JYOTHI Institute of Engineering and Technology, Hyderabad. In the previous video, we have discussed about the software engineering design part, that is modeling with UML, and in this video, we are going to discuss about the use case diagrams in UML. So, out of 9 UML diagrams like we have discussed in the previous video, so with the help of multiple diagrams only it is possible to represent the complex applications also. So that you can do it with the help of various types of diagrams. Out of all these 9 UML diagrams, the first diagram is use case diagram. So this you can represent graphically with the help of ellipse. So use case diagrams, what is the use of this one is, it is to visually represent the interaction between the use cases and actors in a system. What it contains actually, it contains the use cases, actors, relationships, and packages, and nodes and constraints. So these are the key elements are included in this particular use case diagram, and this will be used to represent the interaction between the use cases and actors. So this will be illustrating how the different users or actors interact with the various functionalities, like whatever the main functionalities you have identified in your application, that will be represented with the help of use cases here. So it will shows the properties of with other UML diagrams, and it will clearly shows the user interactions with the help of use cases. And first one is actor. So actor is like here you are representing, it is like when you take the example ATM machine, the customer is interacting with the ATM machine to withdraw money. So that customer or the user can be represented. It may be a person or a system or a device, whatever it may be, that external entity you can represent it as a actor. So here what are the characteristics of the actor? So like actors do not represent the individual users but roles in the system. Like when you take that if the user may be a role, or admin may be another role, or some other special role will be allocated. So that roles will be represented with the help of use cases, with the help of actors. So here when you take a online shopping system example, so here the Ramesh buying a product, so his role is buying. So that will be represented here with the help of this particular actor. And an actor should have a descriptive name reflecting its role, what exactly is doing, that you can represent as a role. So actors initiate the interactions with the system to execute the use cases. So what is the purpose of this particular actor? What exactly is doing with the machine? So what exactly is doing with the system, that you are representing in the help of interactions. And there are two types of actors. One is active actor, second one is passive actors. Active actors are like whenever you initiate a use case, like you are going to the customer is like placing an order, so that you can represent it as a active actor. When it comes to passive actors, so here the use case, whatever the use case is participating in this particular the interaction, it will not be reflected on the screen, but in the back end it is doing. Like suppose example banking system, in this verifying a payment, that will be done in the background. So they are like passive actors. So here you can represent it like actors, you can represent as stick figures also. So in this UML diagrams. And coming to the representation that we have already discussed in the previous video, like actors can be use cases can be represented with the help of ellipse shape. So here this particular ellipse shapes, again when you write something about that particular use case, there are simple names we have, also we have some path names. So simple names will be represented like this. When you see the right side picture, order product or validate users are simple simple names. When it comes to path name, like you are writing, whenever you write the code in C++ or Java, like when you are inheriting something or you are calling from the base class, there you will you do it with the help of scope resolution operator or colon. The same thing you are representing here. This is called path. So from the library base class or base object, so you are doing the make reservation is the next use case you are doing. So this is the way you are accessing that particular element. So here online shopping system, when you take the example, so here the purchase product, whatever the product is there, so that is called it as a use case. And under this, so a user James buys a gaming console using a debit card. So he is buying the product with the help of debit card. This is the scenario you are applying. So for that you are taking the use case called purchase product. And this use case, how it is looks like solid ellipse, and use case must be inside a system boundary, because it should be under the area, so then only it is possible to connect with the machine. So then only you have a control on that particular elements. So that you are doing with the help of an actor. So between the actor and this particular boundary, you are doing the relationship, you are making the relationship with the help of association. This is the way you are representing. And you can also have the relationship between the use case and use case, and use case and actor and actor also. These are the three ways you can make the relationship. So here the association, that is the solid line, you can use the arrow if you want to make a unidirectional association, or you can remove the arrow if you want to have a bidirectional relationship between these two elements. So here whenever you want to show like relationship between the actors and use cases, so this particular association shows the who performs what action. So that will be represented, and the association rules are like every actor must be associated with at least one use case, and an actor can be associated with multiple use cases, and multiple actors can interact with a single use cases. That is the cardinality that we have discussed in the previous video. So here you take an example, customer and bank employee both will interact with the open account and deposit funds. So that both like interacting with that particular operation. And next, along with the use case elements, we are going to check the use cases and their flow of events. Like it is going to describe how a use case executes from start to finish. So that will be represented with the help of some sequence of interactions between the system and actors. So here, this like you take example ATM system. When you validate a user, how you are validating, like with the help of a valid debit card, valid PIN number, and valid account and sufficient balance in the account, then only it is possible to complete the transaction withdraw money operation. So that you are doing with the help of use cases and flow of events. So when you check this particular use case main element, so here you see this main flow of events are first user enters the PIN using the keyboard, keypad, ATM keypad, and then the system validates that PIN, and if the PIN is valid, then the system grants access. And these are the main flow of events. But sometimes what will happen while entering the PIN, sometimes he may forget the PIN number, he may enter the wrong PIN number. So that you are going to represent it exceptional flow of events, like user cancel the transaction before entering a PIN, or user clears and re-enters PIN before confirmation, or if an incorrect PIN is entered 3 times, then access is blocked for 60 seconds. So these may occur while performing this particular transaction. Maybe he forgot the PIN number, maybe he entered the wrong PIN, or maybe some other problem like he stopped the operation. So these are also we are going to show under this particular use case diagram, that is called main flow of events and exceptional flow of events. And how to organize these use cases generally, like you can do it organizing with the help of a package, and you can also make the relationship between these particular elements. So that you are doing with the help of three things. One is a generalization relationship. Whenever you want to make the relation between the actors, like different types of users are there, like you have a normal customer or retail customer, or like he's a savings account he's maintaining or current account. Likewise, the admin also using the same machine. So there you can apply this particular generalization based on his behavior. So normal user, admin, these two are comes under customers of that bank only. And include, so include and extend, there are the two stereotypes you are applying. What is the stereotype? Is like it is going to represent the behavior of that particular element, like what kind of relationship you are maintaining and what kind of action you are going to perform. That mandatory case is you are going to continue. Like suppose you are doing online shopping, there are some steps, flow of events, like you are going to browse the product, you're going to add the item into the cart, you're going to enter the address details. So these are all like step by step you are including, then only it is possible to make the payment. So these are all representing with the help of include. So this you can apply the relation stereotype for the dependency relationship only. Then extend, this is like a special case, like suppose a use case that optionally adds the behavior to another use case. It will not occur all the times, only in a special cases. Like suppose when you enter into that ATM room, so obviously you always enter a correct pin number only in some cases you will forget the pin number. So that is called it as a special case, like extends you are doing. So with the help of a extend relationship or extend stereotype, this will be represented. Otherwise, always in a general case, you are using include only. And this, if you see this right side picture, so there you can see that there are various types of elements. First, when you see that use case is represented with a normal name, that is like check password, place order, rush order, validate user. And also you can represent the same thing with path name by using a scope resolution operator. Two ways you can represent, and you can connect these use cases with the help of relationships like dependency and generalization. And I told you just now, you can apply two stereotypes, include and extend. Include is the general case, extend is the special case, exceptional case, like that. So these two you can apply as stereotypes to the dependency relationship here. So these are the ways you are connecting the use cases with the help of dependency, with the help of generalization. So here generalization, in the previous video I told you, this is also called as the inheritance relationship. This you have already studied in object oriented programming system subject. So here when you take the example ATM system, like you are going to check the functionality, validate user. So there a system may validate a user using pin or retinal scan. Two ways it is verifying, it is validating. So all these verification methods are specialized versions of validate user. So then these are all comes under similar category. So that's why what you are doing, if you see that right side image, so under that use case diagram, validate users are two ways. One is retinal scan, second one is check password. So these two comes under same family. So that's why you're applying the relationship called generalization. And without validating the user, you can't place the order, you can't track the order. That's why you're using dependency relationship. In the previous video, I have discussed like one object is totally depend on the another object. Without that, this object does not exist. So wherever there is a possibility, so then you can definitely apply this particular dependency relationship. Then include relationship, just now I told you. So whenever there is a flow of event, like one after the another, like browsing the product, adding into the cart, and then entering the address details, these are all like continuous flow of events. So there you can apply this particular include stereotype. So there we are using this particular. So this can be applied only to the dependency relationship. Then extend, I told you, whenever there is a special case, like suppose when you take this year-end sale, Amazon is going to give like on Christmas sale. So special offers are there, not all the time. So that time it is giving some additional coupons or some discounts or some other things. So that special cases will be represented with the help of extend stereotype here. This can be applied to the dependency relationship. So here this will be extended only when certain conditions are met. Then, so this is the final representation of the use case diagram, how to model the behavior of an element. So it consists of use case diagram consists of use cases and its relationships and their include and extend stereotypes, all those will be represented. So first what we need to do, first identify the actors who are going to interact with this system, and also organize all those actors with a simple names or a specialized names. Then for each actor, so the consider the primary ways in which the actor interacts with the element. So is it a direct connection or indirect connection? Is it a normal connection? If it is normal, then you can use the association. If it is a special connection, then you can use generalization. It is fully depending on that other object, then you can use a dependency relationship. So likewise, you can check wherever it is applicable. Based on that, you can apply the relationship, and wherever it is eligible, so you can also you can also use include and extend stereotypes. So likewise, you can distinguish the behavior of that particular element clearly with the help of all these elements. Then so when you take any use case, any diagram, at the end of the diagram, we are going to write the common modeling techniques. So what are the possibilities of the each diagram that you can represent under this CMT, common modeling techniques category? So here what we are doing is, first you can model the context of a system. This use case diagram is also called it as a contextual diagram, or the behavior of that application, what exactly it is providing the service to the customer, that will be represented with the help of this diagram. That's why it is a context level diagram. So it is going to show what the actor is doing with this system, what the user is doing, the functionality that will be represented under this use case diagram. And also you're going to specify their role, also you're going to specify their interaction, everything you're going to specify clearly in this use case diagram with the help of key elements. Then second one, to model the requirements of a system. What exactly required? So first you're going to identify the is it a internal functionality, or it is going to interact with the outside system. If it is interacting, how to connect, how to make the relation, and what type of users are interacting, or is a general users or specific users are using this particular system, and how these interaction will be done between the each use case, and between the actors and use case, and between the use case and use case. All those will be represented based on the requirements only, and based on the functionalities which you have identified mainly. And third one, here it is to model the context of a system. Here this is the way the complete use case diagram. See this right side. So there are actors, there is a boundary between that use cases and actor, and there are some relationships. Also we are using stereotypes, normal relationships, all are there. So here in under the context of a system, that is to model the context of a system, this is the common modeling technique. Here what we are doing is, first we are identifying the actors that surrounds the system. Who are the actors in this particular example? Yes, there are two types. One is user, second one is cellular network. These two are the actors. Second, organizing the actors that are similar to one another. Wherever there is a similar behavior, there you can apply this particular generalization relationship. Then for better semantics, provide a stereotype, because to understand it very easily, this is not the normal relation, this is not a special relation. Likewise, wherever there is a possibility, yes, here this is the special case, then you can use that particular extend. So likewise, it has to satisfy the condition to meet that. So like that, so we'll add some semantics with the help of a stereotype to the actor. And finally, create the use case diagram with these actors and specify the paths of communication for each actor to the system use cases using association relationships. So with the help of mainly between the use case and actor, we always start with the association relationship, and between the user and the actor, between the actor and the actor and the use case and use case, we'll use these particular relationships like dependency and generalization. So generalization will be applied both, like between the actor and between the use case and use case, and dependency will be applied between the use case and use case. So this is the final use case diagram. Left side, if you see this, there are two types of customers: individual customer, corporate customer. So whenever there is a similarity, then you can apply this particular generalization relationship. And you can see the boundary of that credit card validation system. And there are mainly 4 functionalities, like perform card transaction, process customer bill, reconcile transactions, manage customer account, like that. So on the left side, we have a mainly users. On the right side, we have a mainly admin related roles, like retail institution, sponsoring financial institution. Those will be represented, because so this should be represented clearly. So who are using this particular product, who are using this functionality, so that will represent on the left side users, and the right side like admin related persons. In the middle of that particular area will represent the use cases. Whatever the functionalities you have represented, that you will represent with the help of use cases here. So this is the way you are representing. So first we'll identify the actors, then we'll model the requirements, then we'll establish the connection between the actor and use case, then you will identify the normal relationships and special relationships. All those you will do with the help of these particular common modeling techniques. Then at the end of the discussion of this every diagram, we are going to discuss one topic, is forward and reverse engineering. What is meant by this forward and reverse engineering? In the previous video, in the first slide, we have discussed software development life cycle. In the software engineering, we are going to develop under various phases. We are going to develop a software, various phases like requirements gathering, analysis and design, coding, testing, maintenance. So from the design to coding, that you can reach with the help of this particular supporting design tools like rational rows, star UML, or some other tools you have, visual paradigm. With the help of all these tools, you can construct the diagram, you can construct the design, and you can simply convert into the code. That is called it as forward engineering. So what is meant by forward engineering? Constructing the code from the model. So that is called it as, not the 100% code, only that introduction part, that is initiating of the member variables and initiating of the member functions and the class, whatever the class you have declared, that you can generate the code automatically with the supporting background languages like C++, Java, C#, Python, all those. With the help of that, you can generate the code. Without writing the code, you can generate the code by constructing this particular diagram. So for that type of concept is called as a forward engineering, like forward design to code, that is forward engineering. Reverse engineering, what you are doing here is simply you are going to design, you are going to generate the model from the code, that is reverse. So from the code, you are going to generate the model. So that is called it as reverse engineering. So these two will be done for every diagram, but mainly 100% you can achieve only in one diagram, that we will discuss in the next coming classes. So in here, after discussion of the every diagram, will have this particular discussion, forward and reverse engineering. So these approaches you can apply in the software development life cycle. So this is about the forward engineering steps. So like you are identifying the use cases, you are defining the flow of events, and you are generating that test scripts. Also you are simulating the test runs, and finally that whatever the tools you are using to test, all those information will be maintained as a main flow of events and exceptional flow of events here. So when you take the example for this e-commerce, suppose use cases, what are the use cases you are having? One is add to cart, second checkout, third one payment processing. who are the actors involved in this particular processing. One is customer, second one is payment gateway, third one is inventory system. Likewise, what are the possibilities, test scenario? Like you can check a customer successfully places an order and receives confirmation. So these things you can do it under this particular category. And coming to the reverse engineering, so you're going to check like banking system. So like who are the actors? Customer, ATM, bank server, and the use cases: withdraw cash, deposit money, check balance. All these things are the main functionalities. So you're going to represent it as a use case. And how you are doing this reverse engineering goal is like you're going to generate the model from the code, like document existing system functionalities for maintenance or upgrade. This is required. So what are the main functionalities, what are the main classes, what are the main elements, all those we need to generate. Then it will be useful for the maintenance or for next upgradation. So these are the topics that we have discussed in this video. Is about the use case diagram, how it will be generated, what is the use of this, and it is going to represent the contextual behavior of the system. So that's all about the today. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.